Hello, my fabulous fifth graders. Today's lesson is on comparing fractions. And simply enough, our I can statement today is I can compare fractions. There are a couple of ways that we can compare fractions, and we're going to learn about two of them today. Let's investigate this. What are some ways to compare fractions? Well, today we are going to learn about two different ways to compare fractions, especially fractions that have different denominators. There are two ways that we'll learn about today. One is using models, which are these that you can find over here. They help us model parts of a whole. Or the other way is to find the least common multiple, and we use that information to make common denominators. Since we can't compare fractions with different denominators, we find a way to turn them into common denominators using equivalent fractions. First, let's practice using models. The directions say you compare the fractions by using models. Use the symbol less than, greater than, or equal to. And we're trying to understand when we have the fraction 3/4 and the fraction 5/8, which is greater. We're going to start by understanding that our fractions are a fraction of a whole. Our whole is represented here with our blue piece. Next, we're going to represent 3/4 using models. I have taken the 1/4 piece and I have laid out 3 of them to represent 3/4. This is what 3/4 of the whole would look like. Next, we're going to represent 5/8 using the models. Here I have taken the 1/8 model and laid out 5 of them to be able to represent what 5/8 of a whole looks like. Now that we have used models to represent these values, we can see which represents the greatest amount. 3/4 is greater than 5/8. So we are going to write 3/4 is greater than 5/8. Now, if you're like me, you would never be caught dead without your handy dandy little fraction models that you see over here. You probably carry them with you wherever you go. But what's a mathematician to do when they've forgotten their fraction models? How on earth can they compare two fractions that have two different denominators? Well, to do that, they're going to have to turn both fractions into equivalent fractions that have the same denominator. In order to do this, we need to review what we've learned about factors and multiples. We have been working a lot in the last week with factors and finding the greatest common factor, which we have been using to simplify a fraction. Here, they've reminded us how to find the factors of 12. Factors are all the numbers that divide into another number evenly. Another way to think about it is all the numbers that can be multiplied to achieve a product. So here are the factors of 12. 1 and 12 are a factor pair. 2 and 6 are a factor pair. 3 and 4 are a factor pair. So down here at the bottom, they've told us that 1, 2, 3, 4, 6, and 12 are factors of 12. These are all of the factors that you can find that will divide evenly into 12. But in order to compare or add or subtract fractions that have different denominators, we'll need to remember what we know about multiples. Multiples are the numbers essentially that you say when you skip count by a number. For example, here they found multiples of 12. Multiples of 12 are 12, 24, 36, and 48. Down here you'll notice that there's a ... because you can keep counting. You can skip count by 12 literally for infinity. So multiples of 12 also go on for infinity. One way I like to remember the difference between factors and multiples, I remember that factors are few and multiples are many. With fractions, we take what we know about multiples and we can take denominators that are different and use what we know about multiples to create a common denominator. A common denominator lets us compare, add, or subtract fractions. So we find the least common multiple, and we use that to come up with the least common denominator of two fractions with unlike denominators. Let's try an example. Here we have a problem where Trevor made 2 out of 3 goals and Tyler made 5 out of 6 goals. Who made the greater fraction of goals? Here we have two fractions that do not have common denominators. We're going to find the least common multiple of the denominators to see if we can change that. So let's think multiples of 3. Let's skip counting by 3. 3, 6, 9, 12, 15, 18. Now let's find some multiples of 6. 6, 12, 18. If you're like me, you've noticed that we can find 6 and 12 and 18 on both lists. But to save us a little bit of work, we are going to work on using the least common multiple, the lowest of these three numbers that they have in common. The least common multiple of 3 and 6 is 6. Now we take this information and we try to find equivalent fractions with a denominator of 6. So my goal is to turn both of these fractions into an equivalent fraction with a denominator of 6. Now, I have to think to myself, what did I do to this 3 to turn it into a 6? Well, I have to multiply it by 2. Because of what we know about our big 1, whatever we do to the bottom, we must also do to the top. So 2 times 2 gives me 4. 4 6 and 2/3 are equivalent fractions. Now let's try this one. We want to turn 5 6 into a fraction with 6 as a denominator. Hey, wait a minute. We've already got 6 as our denominator, so we really don't have to change it at all. It's kind of just like multiplying by 1. Now we have 4 6 and 5 6. Now that we have common denominators, we can just compare the numerators. So we've got 4 6 and 5 6. Since the denominators are the same, we compare the numerators. Since 4 is less than 5, we know that 4 6 is going to be less than 5 6. So that means 2/3 is less than 5 6. So it was Tyler who made the greater fraction of goals. We can check our answer with fraction models. Here we've got 2/3, and here we have 1, 2, 3, 4, 5, 6. As we see, 5 6 is the greater part of a whole. So 5 6 is greater than 2/3. 2/3 is less than 5 6. Let's try another example. Here they're asking us to compare 3/5 and 1/2 using the least common denominator. That means we need to find the least common multiple of both the 5 and the 2. Well, multiples of 5. That's like skip counting. 5, 10, 15, 20, 25. Now, let's find the multiples of 2. 2, 4, 6, 8, 10, 12. Now we need to find the least number that's on both lists. I see that 10 can be found on both lists, and no number smaller than that is on both lists. 10 is the least common multiple of 2 and 5. So we're going to take this least common multiple and find equivalent fractions with a denominator of 10. We want this fraction to have a denominator of 10 and this fraction to have a denominator of 10. So we have to think, what do I do to a 5 to turn it into a 10? Well, I need to multiply it by 2. Because our big 1, we have to have the same number as our numerator, and multiplying our numerator and our denominator. We're also going to multiply our numerator by 2. 3 times 2 is 6. 3/5 and 6/10 are equivalent fractions. Now let's try our other fraction. We want it to have a denominator of 10, so I have to think, well, what do I do to a 2 to turn it into a 10? Well, I need to multiply it by 5. And as you'll see here in our big 1, if I multiplied the denominator by 5 to get 10, I must also multiply the numerator by 5 to get 5. So 5/10 and 1/2 are equivalent fractions. Now we compare 6/10 and 5/10. Much easier. Now that we have our common denominators, we can just compare the numerators. Since 6 is greater than 5, we know that 6/10 is greater than 5/10. That means the same thing as saying 3/5 is greater than 1/2. Let's check the models to make sure that we're right. We see that we have 1/5, 2/5, 3/5, and we have 1/2. As you can see by comparing the models, 3/5 is a greater part of the whole than 1/2. Let's try one with a word problem. Here they ask, a recipe calls for 5/8 cup of brown sugar and 2/3 cup of flour. Which ingredient has the greater amount? So we need to compare these two fractions. We have 5/8 and 2/3. Since they don't have common denominators, we need to find common denominators by looking for the least common multiple between 8 and 3. Well, multiples of 8. I get 8, 16, 24, 32, 40. Now let's find multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24. The lowest number that I find on both lists is 24. So my goal is to turn both of these fractions into equivalent fractions that have 24 as its denominator. Now, I need to figure out what to put in my big 1. So I think, what do I do to an 8 to turn it into a 24? If I don't remember my multiplication tables, I can just go back to my list of multiples and count. Here's my 8s. 1, 2, 3. I multiplied 8 by 3 to get 24. And so inside my big 1, I need 3 over 3. 8 times 3 is 24. 5 times 3 is 15. Now let's try this one. What did I do to my 3 to turn it into 24? If I don't remember my times tables, I can go back to my multiple list and count. 1, 2, 3, 4, 5, 6, 7, 8. I had to multiply 3 times 8 to turn it into 24. So the number inside my big 1 is 8 over 8. 3 times 8 is 24, and 2 times 8 is 16. Now I have 2 fractions with common denominators that I can compare. I have 15 24ths and 16 24ths. Now that they have common denominators, I can just compare the numerators. Since 16 is greater than 15, I know that 2/3 is greater than 5/8. 2/3 is the greatest amount. The flour had the greatest amount. So that brings us to the end of today's lesson. Today we learned about comparing fractions, and we learned 2 different ways to compare fractions, using models and using the least common multiple to find the lowest common denominator. So this needs to be on the W part of your whisk. Here's our topic. Here's our I can statement. This is our summarizing problem. Explain why multiplying the numerator and the denominator of a fraction by the same number results in an equivalent fraction. I will give you one little hint. It is shaped like this. Explain in complete sentences why multiplying the numerator and denominator by the same number gives you an equivalent fraction. Finally, here is our questions section of our whisk. I want you to give it a shot to compare these fractions. Try using the lowest common denominator to compare these fractions and see what you get. Then come up with one problem for your table partners to solve. I look forward to seeing what you come up with in class tomorrow.